You can mock SL protocol to handle a dependency on SL protocol. But mocking is not just for SL protocol. Mocking can also be very powerful to handle dependencies in between your own classes. Let me show you a quick example here. So I've created a new namespace, other class dependency. And what I've done in there, I have one class called a path item, which just contains the original string of a path and the converted string of a path. Now, what is the path? Well, if I scroll down, I have a class here, custom path, where I had a abbreviate path, where you could say, well, this is the input path, which is just a backslashed separated list, and then an output would be abbreviated based on Visio would become V, customer would become C, protocol would become B, and so on. So this is a method that has already been tested. So we have a test battery that exists for all of this. So really, we don't want to test any of this anymore. But now here's the tricky part, because I have a class here now called all paths, and all paths just contains a list with path items. And what I have is a method called convert and add path, which grabs the original, does the conversion using the method that I've already tested, and then it adds it to the list as a path item. Now there's a problem here, because I really want to test if the addition works. I want to test if the path item has the values I expect and that it's actually present in the list of values, because what if this is incorrect, or what if someone changes the code and suddenly forgets to add it to the list? How do I manage that? Because easiest way, again, for unit test is you right click on convert and you say, well, let's create a unit test, keep everything default, and here we go. We are inside of a unit test, and it's the same as always. You begin with your usual structure being arrange, act, assert. Now the arrange, well, I want a new class for all paths. So var all paths equals new all paths. There we go. Now the all paths wants an SL protocol, so here we go again. We need to mock SL protocol. So I'm going to type in mock SL protocol, and I need to add a few usings here. Let me actually do that one manually. Use mock, there we go. And SL protocol, let's see if that one works. Yes. So I can do a fake protocol equals new. So this is nothing new, guys. Just creating a fake, adding it in here, and of course I need the actual object. There we go. Now what else am I going to need? Well, if I have a look in what I'm supposed to do in the method, all paths is the convert and add. I need an original path. Original path. I don't have that yet, so let's make string original path equals A. Now, what I really don't want is to have multiple tests overlapping, which is the case right now, because if I provide this, let's make it a bit more clear. So I do views, protocols, test, something like that. Test. If I send that, I could say, well, okay, I know that the code from the conversion will happen in the background and the expected path is going to be VP tests. But this is overlapping. You've already tested this part. You've already tested all of that. So really, that's not what you're interested in, because what would happen now is, imagine if you finish this test and something goes wrong with the conversion. That means the tests for the conversion will fail. The test for the abbreviation method, I mean. But not just that, but your convert and add path method will also fail. And then what is the problem? At that point, you'll need to investigate multiple things. You'll have to be aware of the fact that there is a fixed dependency in there, and it gets messy. How do you remove that messiness? That's by something, in theory, you call it inversion of control. And inversion of control just means that you avoid creating dependencies in constructors, for example, which is a very common one. So let me show you what I mean. In the all paths, you will see that in there, I actually create my custom path class, the one that I've already tested. But I do it in the constructor. That means all paths has a hard dependency on custom path, and there's no way I can mock it. I cannot fake it, because that's kind of what I want to do. I don't care about the actual logic behind the abbreviation. I have that tested. I care about that it makes a path item and that it adds it to my list. So what you need to do here is something called dependency injection to get rid of this, because new is glue. Everywhere you see equals new custom path, that's glue. That means it's forever stuck as that unless you refactor it. So let's go ahead and refactor this so I can do dependency injection. Dependency injection pretty much just means that I'm going to pass custom path along. So I'm gonna say custom path here. And now what I can do is I can say path equals custom path. So this is dependency injection. Instead of doing the new inside of all paths, I'm actually saying, no, let's provide it when you create all paths. So this is inversion of control. The control over creating custom path is now handled higher up. So what does that mean? Well, that means if I now go to my tests, that all paths, the constructor is not correct anymore. No, what I really want is the custom path equals new custom path. But this doesn't really change anything right now, because it's still going to actually run the actual code. So what do I want to do here? Well, similar to fake protocol where I mock as a protocol, I want to mock custom path. However, and here is where the interfaces come into play. As I mentioned in previous video, an interface is very mockable. A normal class is sometimes mockable, but I wouldn't count on it. So in this part, you have an actual class, but I don't want to mock the class. You could write this. It's probably not going to complain too much. But like I said, you are gonna run into issues here. And you really want to avoid doing that. So you could do that on the class itself. However, let's not do that. Let's do it correctly. How do you do it correctly? Well, you need an interface for mocking, and then you can provide an interface. So the easiest way to do that is if you right click, if you do this guy, what's it called again? Quick actions and refactorings. If you do quick actions and refactorings, you can actually extract the interface automatically. So that is what I'm going to do. I'm going to make an I custom path, which just has the method abbreviate path. All right, there we go. So I've now created an I custom path that contains just the header, as it were. It says that an I custom path, I expect it to have an abbreviate path. So then if I go back to my actual quick action, I now see that it has class custom path, which extends or which implements, pardon me, the I custom path. Now that means I can now actually change what I get. So I can say now I just expect an I custom path, and this can also be an I custom path. And there you go. Now I just want an interface of the custom path. So I've done inversion of control, dependency injection, and I've turned it into an interface so it's mockable. And now what I can do is in the tests for all paths, I can simply change this to use the interface, provided, as I've done here, provided to the all paths. And now I have completely decoupled these implementations. So the act of doing convert and add path doesn't really care about what the logic of that abbreviation code is doing. So even if that logic were to fail, it would not fail this test. This test will only fail if what it's supposed to test is broken, which is adding it to a list. So what I can do now is simply say I need to mock my custom path. So I can set up my custom path to say I want to return something specific. So what I can do here is do a setup p dot, and there's not a lot of choices here. I can provide a fake protocol dot, actually, let's do it differently. It is any, because I really technically don't care much about what kind of SL protocol it is, just is any is fine. And in there I'm gonna provide the path that I'm gonna get, which is, again, I really don't care in this particular case, because I know it's just, you know, it's gonna run and that's it. So what I'm gonna do here is just again do is dot it is any string. Now again I need to remember to add my brackets. There we go. And I can assign a return. And what am I gonna return? Well, what about B? Keep it simple and stupid. Let's return B. So original path, I don't care anymore. It can be anything. So now I have a B, an A, and what does this mean? Well, now I can actually run this test and then eventually do the assertion, and it won't be bothered. So it won't have an overlap, I mean. To finalize this now, we can just finish the assert. So we have our inversion of control or dependency injection with the interface now. We've set up a mock, a fake return of value B. If the abbreviation is done, we have the original path A. So I kind of know what my path item expected item will be. My expected item will be a new path item that is saying the original A B. So that's what I expect to get. So let's assert. Well, what can I do first? Well, first let me do an assertion that checks are equal, that the all paths dot values dot length, sorry, it's to count, equals 1. So that's the first assertion that we can do. We can say here is equal actually, or is true. No, let's stick with r equal, and I need to change my way of working here into 1 comma, there we go. Perfect. So now all I want to do is add a message here that says that the all path length is invalid. All path length is invalid. That's the first assertion. But, you know, let's add another one that's a little more specific. So let's have a look if r equal, if my expected item is actually, if I do all paths dot values and I grab the first one out of there. Actually, let me use first.default here as a link query. And again, remember, always a good idea to add a message to say here that the first value does not match. So I've just created this, so let's actually run it. Let's see what it does now. It fails. Isn't that a bit weird? Because it should be working. I have an expected item here. Well, the reason it fails is something you will commonly find is actually something different apparently. Object reference not set to an instance of an object. Excellent. So we have an actual issue here. So all paths convert and add a string. So it's actually happening inside of here. We have a null reference exception. How is that happening? Let's take a look. Protocol. That's a protocol. So I'm providing the protocol. I have the original path. The new path is in there. There's the issue. I have a list which is not actually set up. So nice. I was going to explain a different error that might happen, but it was this guy. So, I mean, perfect example of why unit testing can be important. It's those little things that every single developer, no matter how experienced you are, can forget. So I forgot to initialize my list in the constructor. Very silly mistake, everyone makes it. Let's run the test again and see what happens. Aha, that is the exception I was expecting. So the first value is not matching, but that's weird, isn't it? Because the first value has A, B, the original path has A, and it's going to return B. So how is that happening? Well, it's because the assert are equal actually does the dot equals in the background. And I never actually made a dot equals for the path item, meaning it's going to pretty much check the reference, like it's going to look at the fact that this path item here, I created it in here. So I do a new path item. So it points to a specific point in the memory. Now in my test, I create a new path item here. So even though the content seems to be the same, it's not the same object. So the R equals is going to fail. How do you fix that common mistake? Is by in path item, you generally what you want to do is you want to implement the equals and also the hash code. So you can generate an equals and a get hash code. Doing that, you can actually select what you want to use in those equals. I'm going to say OK, and there we go. That is actually a very basic and quick way to then avoid it. If I run my test now, it should succeed, and it does. So there we go. So now I've shown you inversion of control, and then actually also how to add the equals and the hash set to make sure it works, and actually a nice example of how you can find an actual bug that I didn't even expect to happen this time, but there you go. So this is kind of how you can do dependency injection, which is a way to achieve inversion of control, where you say, you know, new is glue, let's get rid of that new class, move it into the argument list of my constructor, turn it into an interface, and that way it's completely decoupled. Meaning that if something goes wrong in one piece of the code, it won't necessarily go wrong in the other piece of code when testing. So it's specifically for testing here, is that you've removed any dependencies between those classes. It's very important to keep that in mind as you are actually writing your code. Try and already think about the fact, like, okay, I am writing this code and I am suddenly using a class from there and a class from there and a class from there and a class from there, and suddenly I have 5, 6, 7, 8 dependencies. Try and refactor that. Already consider like, okay, maybe I need to split up my class so it doesn't have that many dependencies, and then I maybe need to just provide them to the constructor. And how about I already extract the interfaces? And that way you already have the entire setup ready to be decoupled and tested individually if everything keeps working. Thank you for watching.